Okay, these are the notes for properties of exponents. We're going to start with some vocabulary terms first. First, let's define what a base is. The base is the number that's being multiplied by itself in the amount expressed by the exponent. So the base is the number that is being multiplied. The exponent is the value that tells us how many times the base will be multiplied by itself. Okay, so if we draw ourselves a little diagram over here, x to the nth power. X is what we call our base, and n is what we call our exponent. For the properties and rules here, product of powers property, you see it is illustrating that if you take two exponents with the same base, or two powers with the same base, you will, and you multiply them, you're going to add those exponents together. So for example, if you have 2 to the 5th times 2 to the 3rd, you're going to add that 5 and the 3 together, and it's going to be equivalent to 2 to the 8th power. Same thing if you were to have a base that's a variable. X to the 3rd times x to the 4th will be x to the 7th. So you just add those exponents together whenever you're multiplying powers with the same base. Power of a power property, that means that you have an exponent here on the inside and everything is being raised to an additional exponent. Then you're just going to multiply those two exponents together and keep that base the same. So an example would be 3 to the 5th power raised to the 2nd. If you're following that rule, you would just take 5 times 2, and so that base stays the same, 3, and 5 times 2 is 10. So it's 3 to the 10th. Additionally, the same thing would happen with a variable base. If you have x to the 4th power, and then it's raised to the 3rd power, you would take 4 times 3, and that would be x to the 12th power. Okay, negative exponents. Whenever we have a negative exponent, we keep the base and rewrite it in the denominator of a fraction, and we change that exponent to a positive, and our numerator is now a 1. So we rewrite it as a fraction to force that exponent to be positive in the denominator. So here's an example of that. If we have 2 to the negative 3rd power, then we will rewrite it as a fraction 1 over, and 2, and that 3 becomes positive, 2 to the 3rd. You could continue to simplify this and become, it's 1 over 2 times 2 times 2, which is 8, so 1/8. Looking at if you have a variable x to the negative 4th power, would be rewritten as 1 over x to the 4th. Okay, 0 exponents, anything to a 0 power is equal to 1. So any base. So if you have 5 to the 0 power, that is 1. If you have x to the 0 power, it's equal to 1. For the quotient of powers property, that means that you have a base with an exponent in the top and the bottom. The bases are the same. When you are dividing those, you actually end up subtracting those exponents. So that's what this illustrates here. And you always go in order top to bottom, so top minus bottom. And if you end up with a negative exponent, you're going to end up using this negative exponent property up here. So let's look at 2 to the 4th over 2 to the 3rd. 2 to the 4th over 2 to the 3rd, that's 4 minus 3, which is 1. And anything to the first power will be itself. So if you don't see 2 to the 1st, let's say in a multiple choice problem, then look for that value of 2. If you have x to the 7th over x to the 5th, 7 minus 5 is 2, so it's x to the 2nd. Power of a quotient property. That means that you have a quotient on the inside, different bases. With that exponent on the outside, you can use the exponent for the numerator and for the denominator separately. So let's say you have 5/7 raised to the 3rd power, then that would be 5 to the 3rd over 7 to the 3rd. And you could simplify from there. Same thing if you have variable terms, let's say x over y raised to the 2nd, then that would be x to the 2nd over y to the 2nd. Okay, and we're going to save this simplifying problem for later.